All right, today's lesson is lesson number 62. We're going to be talking about a concept called the average rate of change. This is very similar to slope of a line, okay? So we're going to be calculating and interpreting the average rate of change for different functions. Okay, here's the definition. So the average rate of change of a function is the change in y divided by the change in x. And again, that's very similar to slope. It has the same formula that you are probably used to from a line. Okay, but instead we can use this formula for any type of curve. So looking here at the graph over here, I can think of some point here as my x1. Say this would be my initial x point that it's looking for, and then some point over here might be x2. And I would look for the corresponding y values. Right, so this would be y1, and then this would be y2. Okay, so basically what you're doing is thinking, okay, if I had a line between these 2 points, what would the slope of that line be, right? So this formula is just calculating slope. So if there was a line between those 2 points, it would be the slope of that line. Okay, even if there's not an actual line there, we're finding the average rate of change between those 2 points. Okay. All right, so moving on, our first 2 examples are here. Okay, so in this first example, it's asking us to find the average rate of change from x equals 0 to x equals 3. So I look at the graph and I say, okay, so what's my point when x equals 0? That's right here, which is the point 0, 0. Okay, so now I have my x1 and y1. Then I'm looking at what is the point when x equals 3, right? It's asking from 0 to 3. So at x equals 3, I'm at this point, which is 3, 5. Okay, now I'm going to calculate the slope between these 2 points. I could always use the counting method, right? I could count the boxes up and over like you would for a line. But I'm going to go ahead and use the formula. So I have y2 minus y1 over x2 minus x1. I'm going to plug in my values now. So y2 is 5 minus y1 is 0. Divided by x2 is 3 and x1 is 0. Okay, subtracting, I get 5 over 3. And that is my final answer. Okay, so that's all I have to do for these problems. It's just basically calculating slope. So this tells me the average rate of change between these 2 points is 5/3. So it's basically, if I were to make a line between them, the slope would be 5/3. All right, moving on to example 2. I'm looking for the average rate of change from x equals 1 to x equals 4. So at 1, I have this point here, which is 1, 2. And then at 4, I have this point, which is 4, negative 2, 5. Negative 2.5, excuse me. Okay, so I have these 2 points, and I'm thinking, what would happen if I had a line between them? What would that slope be? So I could actually count the squares here. I just have to be careful that I'm actually going down 1 unit. You'll notice the scale for my y-axis. Each line is actually 1/2 of a unit, so I just have to be aware of that. So as I go down, I'll go down 1, 2, 3 units, and I see I have a nice point at 3, negative 1. That point falls right on that line, so I could just go over there. So that's going down 3 and over 2. So the slope of this line, remember, it doesn't matter which 2 points I use on a line to find the slope. So I could use this other convenient point here, and I get negative 3 over 2. Okay, I could also use the formula, right, y2 minus y1 over x2 minus x1, and plug in the points that it was asking for that are on the parabola, or on the quadratic. So at x equals 1, I have y equal to 2, so that point, so my y2 value, that's x1 and y1, and then for my second point, I'm at 4, negative 2.5. So I have negative 2.5 as my y2, and then 4 is my x2, and then y1 is 2, and x1 is 1. Okay, so just plugging in those points. Negative 2.5 minus 2 gives me negative 4.5. And then 4 minus 1 gives me 3. Okay, I'm going to rewrite that over here. And that fraction, I have a decimal and a fraction, so I don't really want both of those things going on. Just one would be okay, but just mathematically doesn't really look nice. So instead I'm going to multiply both of these by 2. So multiplying the top and bottom by 2 gives me the same value, but it's gets rid of that decimal. Right, so negative 9 over 6. And then simplifying that, I get negative 3/2, which is exactly what I got the other way as well. I could have also counted all the way down to this original point. Okay, so that would be going down 1, 2, 3, 4. The problem is after that I have to go down a half of a unit. So it would be down 4.5 over 1, 2, 3. Okay, so I do end up with this same, I end up with this fraction here, which we found reduces the same way. Okay, so a few different ways to approach these problems. The next one is comparing two different populations. So we could say these are two different locations maybe. Some scientists release 100 fish into these two different streams and see how the population is doing. So number 3 says find the average rate of change of the population from year 0 to year 4. So I'm looking here and here on my table. And I'm just going to go ahead, I can do the same equation, right? I'll have 428 minus 100 divided by 4 minus 0, right? Doing y2 minus y1 over x2 minus x1. Okay, so again, plugging in those values gives me this. And that's just 328 over 4. Dividing that, it's 4 goes into 328 an even amount of time, so I'll divide, and that gives me 82. Remember, this is talking about the number of fish, right? It's a population, so it's not, we don't just want to give them a number, we want to put the correct unit on it. So this is actually 82. It'd be fish per year. Okay, and how we would understand this is that it's saying from year 0 to year 4, the population increased at an average rate of 82 fish per year. Okay, so each year they got about another 82 fish. Okay, over the 4 years they averaged 82 new fish each year. Alright, so moving on to number 4 now. I'm going to look at what's happening at year 0 and year 4. Okay, so again, it's asking me the same question, but it's a different population, and they're giving me a graph now instead of a table. So the numbers are going to be a little different. But I see at year 0, I also start with 100, but then at year 4, I end up with 300. So I can actually just count the spaces here, right? So I'm going up 2, then over 4. So going back to what I know about slope, right, I know, oh, okay, the slope must be 2/4, 2 over 4. Oh, but I should reduce, right, so 1/2. But something interesting to note here, right, take a second if you're watching the video for the first time, just pause and think about this solution, okay? Think about if I've made a mistake here. Alright, so if you look closely, what the problem here is that when I went up 2, I just counted the boxes, right? But again, that scale is very important. So each box represents more than just one, right? So going up 2 boxes means I actually went up 200 fish, right? And going over 4, that scale is okay. Each box just meant 1 year, so that's still divided by 4. Okay, so these are incorrect. I want 200 over 4. Okay, and that's going to reduce to 50, which means that this population increased at an average rate of 50 fish per year over this 4-year period. Oh, sorry. Alright, sorry. So here are 2 final answers. For 3 and 4, we get 82 fish per year and 50 fish per year for the different populations. So we could guess that maybe the first stream has some better nutrients or something. For some reason, their population is increasing faster than the population in the second river or whatever they're looking at. Okay, so for 5 and 6, we have the same table and graph, but now we're looking at year 4 to year 8. Okay, so in the table, I'm looking here and here. And if I use the formula and reduce, I get 82 fish per year again, actually. Okay, now over in number 6, if I look at 4 and 8, for the y coordinate is 300. Up here at 8, I'm kind of in between 800 and 900, so we decided to call that about 860. Okay, and then, so that would be your x1, y1, and then your x2, y2. Right, so plugging those values into the formula, we get 860 minus 300 is 560, divided by 8 minus 4 is 4. Okay, and reducing, that gives us 140 fish per year. Okay, so now in this second span of 4 years, it would seem that the second stream is doing much better than the first. So maybe some conditions changed in the environment or something like that, but this is just where we might see this applied in real life, would be something with populations. All right, so that is it for today's lesson. Thank you guys, and I'll see you tomorrow.